So when I look at this stack that I have, stack object that I have in memory, or int stack, this is what I see. So far, you know, this object is, if it was this big box, right, all alone, and it had this array of 5 integers, something like that. I need to be able to, so this array of 5 integers, which in itself is like a little something inside this box, right? So I'd like to use it as a storage of elements being pushed and into the stack and out of the stack by pop. So, but I need to be able to, so let's just, for the sake of simplicity, get rid of this stuff and just imagine that everything that we're trying to see is happening inside of the stack. So somehow we need to be able to have essentially something we can call as a stack pointer or top of stack, right? Some kind of variable, an integer variable, which simply says use this, then it says no, use this now, use that now, and so forth. So essentially we need the value that says if it's 0, then it's pointing to the first element, because inside the array this is index 0. If it's 1, right, if top of stack is 1, it's pointing to this element, element 1. If it's 2, it points to this element, 2, right, and so forth, right? So we need another variable. So when you need another variable, of course, this variable has to be available to every object. Therefore, some integer value top of stack needs to be added to the implementation of our stack, and we go back to the header of our stack, and we can say, oh, we need another integer that says top of stack, for the lack of better name, right? So we declare an integer, and it's very easy to add that other integer to the definition, to the scope of our object, right? Just add another integer, and it'll be created every time a stack object is created. My only concern is that it needs to be initialized, right? It needs to be initialized. I'll show you 2 ways to initialize it. Simply, you can say this, right? You can say, oh, I want to initialize it because naturally we want to make sure that originally the value, the top of stack, is basically pointing to element 0, right? Initially. All right, so that's why it would be natural to initialize it, to give it the initial value equals 0. The member initialization, like inline member, data member initialization, was added to C++ only in 2011 standard. Prior to that, your only option would be to write a constructor function for your class. So as you can see, this can be done this way, but I will also demonstrate to you how to add a constructor. So we discussed constructors last week, but I will say, okay, maybe we need constructors here inside the int stack, because we may need to do extra things also beyond just initialization of the top of stack. So this way, we can basically build the entire functionality. So int stack with no parameters is the declaration of the default constructor. So what is constructor? Constructor is a function. In Java, constructor is a method. In our environment, constructor is a function, member function of our int stack class, which has exact same name as the name of our class, and this is how compiler recognizes it to be the constructor, number one. And number two, it's a publicly available function, so which will be invoked basically anytime an object is created, right? So anytime an object is created, anyway, without any kind of parameters, what's going to happen that this function is going to be invoked. As before, with push, pop, top, and size, we need to take this function prototype and go to our implementation file in stack.cpp, and perhaps somewhere close to the top of the file, basically do the same thing. First of all, we need to prefix this function name with the scope from where it comes from, which is in stack, right? And of course, get rid of the semicolon, which is a syntax error inside the implementation file, and instead give it a body. Okay, and so what we could do here, we could say, let's just, let me pull it back to the previous tab group, right? So this time, what I could do, I could simply say top of stack, top of stack equals 0. Okay, so like we said, since 2011, you can do this, right? But if you wanted to have a separate function which does this explicitly, you could have done just that. Add a constructor to your class. When constructor takes no parameters, it's called a default constructor, so it invoked anytime an object is created, and we can do something like this. But there is a better way of doing it, is actually using the initialization list. So the thing is that we said before that when our main function or some other function which is trying to use the stack object is trying to create it, two things happen. Thing number one, the memory is allocated because compiler knows how much space it needs to accommodate all of this, number one. And number two, it will invoke the constructor. So by the time the constructor is invoked, this style of member initialization, which is very typical for Java, in C++ considered to be inefficient because we can execute initialization of our data members inside the class as the memory is allocated. And for this, we use initialization list. So today, new thing is initialization. This is something new that initialization. I don't know what I just did. Initialization list. Full name would be constructor. Constructor initialization list, which is using the column, right? So before the opening brace of the actual body of our constructor function, what we do, we insert the column, and then we basically say top of stack, which is the one that we're trying to initialize, would be initialized using the constructor syntax, like that, right? So this is similar to saying, as before, top of stack equals 0. Initialization list is a preferred way of initializing data members inside the constructors, okay? So this statement I will keep in view, but I will simply comment this out. So in the world of C++, it's very typical to see constructors which have empty body, but the work is actually done by the initializer list. Okay, so it's just a little syntactical element, but it's good to remember that this, and notice that you don't need a semicolon here. This is not a statement. Initialization list is because you can have other members and you can add them like that. and you initialize them by using the comma operator. So if later on we add other pieces to our stack, we'll be expanding the initialization list later on. But right now, all I want to do is to initialize this top of stack with 0, and this is how I would like to do that, right? Using the constructor initializer. I think the right name is initializer list. Constructor initializer list. That would be the right technical name for this syntax element. So, and yet again, we could use this, just simply equal 0. That does the same thing. For now, I will just keep it in view, but comment it out, because that syntax is available, fully usable, but I wanted to demonstrate both ways of doing this. When would you prefer the data initializer? When you have multiple constructors and each single one of them supposed to do this, then clearly you can just go ahead and just use this to say anytime an object is created, use data member initializer directly in line equals 0, and it's going to be happening in not just one constructor, but if you have multiple constructors, you will you can use that. So anyway, the two versions here are available. So this time, right, when the object is created, when we say when our main function says int stack st, and all of this is created, basically top of stack will be populated with 0, right, as a result of us adding this constructor. So as soon as we say this, in fact, we should be able to actually observe it, right? If I say build, right, make sure that I build, everything seems to be building fine. If I place a breakpoint by simply clicking on this field, or if I say right click and say breakpoint, insert breakpoint, similar right clicking is available in code blocks if you're using code blocks in your when you try to play with the code at home, right? So then I can say debug, start debugging, right? And the program will start and the debugger will stop before executing this, right? And if I say debug, step into this statement and show me everything that happens during the execution of the statement, which is step into or F11, and this little arrow shows that this is about to happen, right? I stopped here for you to see it, and it's about to happen. If I press F11, guess what happens? We're jumping inside of our constructor. And so this already happened. The top of stack got populated. I'm just going to say, F11, and now I have this in stack with constructor invoked, and of course the top of stack data member is already populated with 0. Unlike top of stack, the actual memory block, which is this thing right here, right? Memory block, which is just an array of integers, right? This thing, which points to the beginning of this array of however many integers I have created. This one contains garbage values. Those were not initialized. We don't know what's inside of them. The memory was allocated wherever object was allocated. Question mark indicates that we really don't know what's there. We have access to memory, but we need to manage it.